if you have a cord or cable or rope or belt rounded on a surface, and you are trying to lift something connected to this belt from the other side, and you are pulling the belt from this side. Keep in your mind, if the weight here equal 100 Newton, for example, I think you need to apply more forces here, more than 100 Newton, to be able to lift this weight. Why? The force here should equal to this one? No, because we have friction between the surface of this curved body and your belt. Keep in your mind, we have two different situations. Just a second. Sometimes we have something here called poly or smooth. Poly, we have a pin here and we have a cable. Keep in your mind, if you have this case, which is a smooth poly, we have a pin here. This pin will allow for this poly to rotate freely. In this case, if you have a force here 100 Newton, this force will be also 100 Newton. Both of them equal. But this is the case because we are neglecting any friction, and it looks like the pulley is rotating smoothly without any friction, or we can neglect the friction. But right now, I'm talking about something different. I'm talking about a circular surface, and this circular surface cannot rotate, And we have the same situation. We have a cable over this surface. In this case, because the surface or the circular surface is not rotating, we should expect friction, too much friction. And this friction will cause that if you have a force here, T1, this force T2 will be different. T2 must be greater than T1 to be able to lift the weight at T1. The relationship between T1 and the T2 is given by this relationship. T2, which is greater, equal T1 on the other side time E to power mu time beta. E is a mathematical expression equal 2.718 or 2.7. You can find it from your calculator, by the way. If you look to the calculator at the button called LN, you can find the value of E. Does that make sense? Mu is the coefficient of static or kinetic friction, whatever, based on the belt. If the belt is moving, it will be kinetic. If the belt does not move yet, it will be static. And the beta is a very good parameter. If you look to this surface, we have the perpendicular on force T2 and the perpendicular to force T1. Both the two lines will intersect, creating an angle in between. This angle equal beta. And we are going to use this value beta in radian format. What you mean by radian format? I mean, if the angle beta, for example, equal 30 degree, this is in degree format. You have to multiply it by divided by 180. Then you convert it to radian value. So beta angle of belt to surface contact measured in radian must be in radian. Don't use beta in degree format. Keep in your mind the applied force T2 will equal, will be greater than the T1 because we have friction here. So T2 must overcome the friction besides the value of T1. I have an example here. This one. Let's start with this one. We are applying maximum tension force that developed in the cord equal 500 Newton. And we have here pulley, which is free to rotate. So here, no friction at A, because we have a pin, and this pin will allow for this pulley to rotate freely. So no friction at A. B and C, we will have friction because we have a cord. This cord or this cable is rotating over this curved surface, and this surface is not rotating. So we have friction here, and we have friction here. Can you tell me the largest weight, not math, the largest weight of the cylinder? If you apply here T equal 500 Newton, so what is the maximum weight of this cylinder to be lifted by this force 500 Newton? So let's start with D. And we have this cord coming down with a force T equal 500 Newton. And we have this cord coming in this direction. So I think, because we are applying the force here, this is T2 and this is T1. Does that make sense? And the relationship between T2 and the T1 equal T2 equal T1 time E to power mu time angle beta. The question is, what is the angle beta? I will draw perpendicular to T1 and perpendicular to T2. The angle between the two lines will be the angle beta. I think this angle beta, if you draw perpendicular here, this is perpendicular to this surface. So I think this angle will be 135, which equal 90 plus 45. So beta will equal 135, but I need to convert 135 to radian. So I will multiply it by divided by 180. So the value will be 2.35 radian. Go ahead and put your numbers. This is 500 equal T1 time E to power 0.25 time 2.35. I can find out the value of T1 will be less than 500. So let me check how can I do it. So I have, this is E to power 0.25 times 2.35. I got it. Divided by 500. 1 divide the answer. T1 will be 277.8 Newton. As I mentioned, you are applying force here 500. However, the force in this cable will be only 277.8. The rest go to the friction between the cable and the surface. Also, keep in your mind, if the force here in this cable 277.8, it will be the same here 277.8. Do you know why? Because this pulley is free to rotate. So the second part is talking about C. I have a force here equal to 277.8. And we have a weight here, which is the weight of the cylinder. That makes sense? So if you assume this is T2, this one will be T1. So just a moment. If you assume this is T2, this one will be T1. The relationship T2 equal T1 times E to power mu to power beta. So beta is, you have to draw perpendicular to this force T2 and perpendicular to this force T1. This is your angle beta. I think it will equal 135 also. So it will degree equal 2.35 radian. So T2 equal 277.8 equal T1 time e to power 0.25. This is the value of mu time beta in radian. So the value of T1 will equal, let me check, 0.25 times 2.35. The value will be 154.4 Newton. So what I can put here as a cylinder, I can put only a weight equal 154.4 Newton. If you put a weight here, I can keep this weight in this position. If you apply a force here, 500 Newton. That makes sense? So this is how to figure out the relationship between two forces passing through a friction on the surface between the belt, between the cord, between the rod, and the curved surface. That makes sense? Keep in your mind, there's a big difference between if you have a smooth poly, which is free to rotate. In this case, the force in this side will be the same on the other side, no difference. This is what I did here. 277 will be here 277. But this one and this one are not rotating. They are not smooth. So we have friction. This is the reason why if you apply a force here 500, it will be here 277.8. If you apply a force here 277.8, it will be a force here equal 154.4 Newton. Does that make sense? The last question I need to cover today is this one. For me, it's very important. Do you know why? Because sometimes you need to save somebody falling from the mountain. So we have two persons. The first one at A has a weight equal 100 pound. So we have a force here equal 100 pound. Looks good. Is suspended from the cable that passes over the quarter circular cliff rock. Can you see? This one is not rotating. So we should expect a friction here. And we have another person, woman with 185 pound weight. The weight of this woman equal 185 pound. Very interesting problem. To hoist him up, trying to save him. And if this is possible, what smallest force must she exert on the horizontal cable? How much force we need to apply here? This one, by the way, is horizontal. So what is the force here? It's a very good point. So we have this quarter. Quarter means quarter a circle. And we have a vertical force here, T2 equal 100 pound. And we have a horizontal force here, T1 exerted by the woman. I'm not sure how much. And we should expect there is friction here. So the relationship between T1 and the T2, I'm sorry. This is T2. The forces applied by the person is T2, and this is T1. So the value of T2 equal T1 e to power mu time beta. Does that make sense? Keep in your mind, if you draw perpendicular to this force, which is vertical, if you draw perpendicular to this force, which is horizontal, the angle beta will equal 90 degree. So beta equal 90 degree, which is 90 times pi divided by 180 to be in radian. So 90 times pi divided by 180, it will be 0.5 pi, 1.57 radian. So go ahead and put your numbers. T1 equal 100 pound, e to power mu 0.8. Wait a moment. The coefficient of static friction between the cable and the rock is 0.2, not 0.8. 0.8 is something else, because it looks like we have two values for the friction coefficient. But the one I'm gonna use between the rope or the cable and the rock equal 0.2. Just a moment. Doesn't work. Anyway, 0.2 time beta equal 1.57. So the value of T2 that must be applied by the woman to save this person will equal 136.9 pound. So this woman would like to apply a smallest value. This is the smallest value to make balance, just to hold this person is 136.9 pound. And we need, what is the smallest force must be horizontal? Yes, the coefficient of friction, and between the, I don't care about the woman. Do you think, yeah, the question is, we are missing something, but the question is, do you think this woman will slide? Yes or no? This woman need to apply a force here equal 136.9 pound. If the woman applied this force to hold this person, do you think the woman will slide or not? Is the woman going to slide or not? This is a good question. So I have another part of the problem related to friction. We have a woman. Assume this box is the woman. And this woman applying a force, trying to pull this woman to right equal how much? 136.9 pound. The weight of this woman, 185 pound. And this woman rested on the ground surface. And we have friction between the ground surface and the woman equal 0.8. Since the force 136.9 trying to move the woman to right, I should expect a friction here between the woman and the ground surface. This friction will equal mu times capital N. The value of mu 0.8. The value of capital N, the force perpendicular to the surface, which is 185 pound. So the friction force between the woman and the ground surface will be 0.8 times 185 will equal 148 pound. So The woman is applying a force 136.9 to hold the person, and we have friction between the woman and the ground surface equal 148. Since the friction is greater than the applied force, no sliding will happen. That makes sense? So this woman will apply a force in this cable equal 136.9 to hold this person at this position. This is the minimum force. And this force will not move or will not push this woman to slide, because the friction here on between the woman and the ground surface will be 148 pounds, which is greater than the applied force, 136.9, so no sliding. Does that make sense?